Today's lesson, section 11.3a, we'll be talking about hyperbolas. So a hyperbola is the set of all points in the plane, which the difference of whose distances from two fixed points f1 and f2 is a constant. So these fixed points are foci of the hyperbola. The hyperbola crosses only one of the axes. These intersections are called its vertices. Okay, so it does have the other values still incorporated, but it's not really touching, so we don't really graph them per se, like label them so much. The foci and the vertices are on the same axis, like with the ellipse, and which is referred to as the transverse axis. Okay, so it's not the major and minor, it's just a transverse axis. The hyperbola is contained by two asymptotes with opposite slopes. Okay, so remember these are going to be centered around or at the origin. Now our equations will look similar to ellipse, but they are a little bit different. Okay, so take notice that instead of addition between your x squared and y squareds, it's minus now. And also notice that instead of the a squared and b squared switching around depending on which axis you're on, or like if it's vertical or horizontal, here your x squared and y squared move around. So if your transverse axis is on the horizontal axis, so on the x-axis, x squared is first. If your vertical axis is the transverse axis, then the y squared is first. So that is something to remember for how you're going to orient your hyperbolas. So a squared and b squared, it doesn't really matter. A squared is always going to be underneath the one in front, but it's not necessarily the biggest value. So that's what's indicated here. So just know that both a and b are positive real numbers that you can get. So your vertices are always going to be plus or minus a comma 0 for the horizontal, or 0 comma plus or minus a for the vertical. Your transverse axis is always still the constant of 2a. It's just transverse will be horizontal for the first one, vertical for the second. Okay, and these asymptotes that we're talking about will be dependent on which one's first. So if it's a horizontal axis, then your rise will be b, so that means you're going up b on the vertical, and then you're going to the right a, so that's why they're switched, because a is like on the horizontal part, b will be on the vertical, and then they'll switch for the vertical one, because a is now on the vertical axis, because that's where your transverse axis is, and then you'll go to the right b, because that'll be on the other axis. Okay, so that's how they get the slopes there. And remember that you're intersecting the y-axis at 0, 0, so that's why there's no value over here, so it's like plus 0 for both of them. But we don't have to write that at all. And then for our foci, they're also on the same transverse axis, so you get plus or minus c comma 0 for the first one, and then 0 comma plus or minus c for the second one. Now here, for hyperbolas, our Pythagorean theorem actually goes back to looking like a normal one. So we have a squared plus b squared equals c squared. Okay, and so our hyperbolas will look like the pictures that I've shown down here. So this one is a horizontal axis. So all your good stuff is on the x-axis. This one to the right will be a vertical. Okay. So now notice that I still use b, and what we're doing is we're creating a what they call central box. I just call it the box. Okay? And so you mark your b value and your a values, so your vertices first. And then to help you write your asymptotes, and this is all it's really for is asymptotes, you can create a box. So you extend this b value with like a line across on both top and bottom, and then you do the same with the a so that you meet at the points. And so these points out here, to the top right, top left, bottom right, you create more points for your asymptotes, with your center. So now you can create a asymptote. So this is an asymptote right here, and this is an asymptote right there. Now I usually use dashed lines, but I'm just drawing it out so you can kind of see it a little bit better. And so that's what I mean by containing the hyperbolas. So the hyperbolas don't cross these asymptotes at all. They stay in their sections. So they'll either be on the right and left parts, or if it's vertical, it'll be on the top and bottom parts of, like, or gaps that are created. Okay? And now, just so you're aware, you do not have to make a central box if you don't want to. Okay, I'll show you both so you can see which one you like better. Because some kids like the central box because it makes it easier to graph your asymptotes. Some kids don't because it's got a lot of stuff going on. Okay, so you can choose to do which one you want. Okay, so example 1, we say find the vertices, foci, and asymptotes of the hyperbola and then graph. So just like with the ellipses, if they're not in the proper form, so if your right side does not equal 1, then you need to divide by that number on the right so that it is in the proper form. So we're going to divide by 3600 here, and so then x squared will be over 144, and then minus y squared will be over 25. And then 3600 divided by 3600 is 1. Okay, so now we're in the proper form, and now we can figure out what our values are. Now, since you're given the equation, you know what a squared is, which is 144, which means that a is equal to 12 when you take the square root. B squared is 25, so that means b is equal to 5. Okay, so now you can use that to help you find your c value. So 144 plus 25, because remember a squared plus b squared this time, will equal c squared. So now put them together, you get 169, and then you square root, that gets you 13. Okay, so now you got all your values, and so now you need to figure out your vertices, foci, and asymptotes. So vertices will be, because x squared's first, that means your x is going to have the value for a, so plus or minus 12, comma 0. Then your foci, same thing, since x squared's first, it's going to have the x part as well, so plus or minus 13, comma 0. And then for your asymptotes, it'll be y equals, now remember, your rise is going to be the b value, and then over a, so you have plus or minus, because you have two of them, and then your b is 5, over your a of 12 equals x, or times x, I'm sorry. So then here, now, this one I don't have enough room, so I'm going to change the scale a little bit. So let's go by 4s. Okay, and I'm just going to do that for my x-axis. I'll keep my y the same because I have enough room that way. Okay, so then go out to here. So there's my vertex. So I get 12, comma 0. Same thing here. Negative 12, comma 0. And then my focus, and I'm going to use a different color because they're so close. Okay, so this focus is 13, comma 0. And then this focus is negative 13, comma 0. Okay, let's go back to our regular color. So now what I want to do is I want to make my central box, and so I'll show it this way. So I went 12 out in both left and right for a value. Now I want to go up 5 and down 5. So 1, 2, 3, 4, 5 up. There's my b value. I don't have to label the b's if you don't want to. Okay, so there's the other b value. Now this one's going to be skewed because I changed the scale so much, and actually maybe it'd make more sense to change the scale if you I want to see this a little bit better. Okay, so then that means, because then it'll be a little bit more proportion for you. So let me draw the circle. Okay, so now I want to draw my lines. So that I create the box. Okay, so then see how I make the corners. So they're at the points where your A and B value are meeting. So it's like saying 12.5 in the top right, negative 12.5 in the top left, negative 12, negative 5 in the bottom left, and then 12, negative 5 in the bottom right. So now you've created these points, and you don't have to draw the points for them. I'm just making a visual for you. With your center, now you can create your asymptotes. And do the same the other way. So then you don't really have to make up any points, so you don't have to like find them yourself. It's just drawing that box to make them or find them. So it makes it easier to draw them. And then from there, now you want to draw your hyperbolas so they match. Now remember, some kids make this mistake. Remember that your hyperbolas are being drawn from the vertices, not from the foci. Some kids put them on the foci and then the vertices are like not touching your hyperbola, which is not correct. Okay, so make sure that your hyperbola crosses at the vertice on your transverse axis, not the focus, okay, or the foci. So let's go back to the other one. So here, same thing, 36 is not the number 1, so I need to divide everything by 36. Okay, so then y squared over, or 9y squared over 36 becomes y squared over 4. And then negative 4x squared over 36 becomes x squared over 9. It gives me 1. And then from there, now I need to do the same thing. So a squared is 4 in this case. So that means it's 2 for a. And then b squared is 9. So that means b is 3. Okay? I still want to find my c value. So 9 squared, or 9 plus 4 is equal to c squared, which gives me 13 for c squared, square root. So c equals the square root of 13. That doesn't reduce or anything, so I gotta leave it that way. So now for my vertice, because y squared is first, that means that it's going to be with the y. So I say 0, comma, plus or minus 2. For my foci, same thing. So it'll be 0, comma, plus or minus the square root of 13. Okay? And then for your asymptotes, it'll be y equals plus or minus. Now here, because you're going up first and it's on, like your vertical axis is the a value, you go up a and then to the right b. So it's 2 over 3 in this case. Okay? So then here, I'll go up 2 for my vertices. And then I'll go down 2, okay, and I'll label them. Okay, and I'll do the same thing for my foci. Oops. Square root of 13 would be a little in between 3 and 4, so let's plug it there. So 0 square root of 13. 0, comma, negative square root of 13. Okay, so now I got my points, and then I do the same thing for the b value. Now remember, like I said in the previous slide, it doesn't matter if a is bigger or smaller in this case. They're going to be interchanging. So b sometimes is bigger, sometimes it's not. Okay. So now let's take those off. Now let's do this without the central box. So without the central box, you graph it just like you would any other line. So here, because you have a slope of 2/3. So I go up 2 from the center. Let's mark our center there. So up 2 to the right 3. There's a point. Okay, so now you want to make a line that way. Okay, and then do the same thing, go down 2 to the right 3. Okay, and so now I do the same thing, have my vertices go approach my asymptotes. Remember, I'm drawing from the vertices, and then that would be my graph. So if you like the one on the right, that's perfectly fine. Go ahead and do it that way. But if you, and this is how I learned it, was letter A, is using the box to help me graph the asymptotes. But like I said, it doesn't matter which one's which. Okay, so do whichever one you feel more comfortable with. Okay, have fun.